What I am about to tell you represents one of the most significant developments in American air power since the introduction of stealth technology itself. If the reporting coming out of the Middle East is accurate, and the details that have emerged are consistent with vulnerabilities that serious defense analysts have documented for years, then we are looking at a moment that will fundamentally alter how the United States and its allies plan, execute, and think about air operations in contested environments for decades to come. An American F-35 Lightning II, the most expensive and most technologically sophisticated combat aircraft ever built, was detected, tracked, and engaged by Iranian air defense systems. And the method Iran used to accomplish that is not a sophisticated mystery that took years to unravel. It is a known vulnerability, a documented weakness, one that has been raised by defense researchers, flagged by independent analysts, and discussed in classified settings for years. The reason you need to stay with me through every minute of this analysis is that the implications of what happened do not stop at the borders of the Middle East. They extend to Taiwan, to the South China Sea, to every theater where American air power has been the foundational assumption of our strategic planning. By the time we are finished, you will understand not just what happened, but why it happened, why it was allowed to happen, and what it means for the security of this nation and every allied nation that has staked its defense on the promise of fifth-generation stealth. Let me begin with what the F-35 was designed to be, because understanding the gap between the promise and the reality is essential to understanding the magnitude of what this incident represents. The F-35 Lightning II program was conceived as the answer to a fundamental challenge of modern air warfare. How do you build an aircraft that can operate in environments defended by sophisticated integrated air defense systems and survive long enough to accomplish its mission? The answer that Lockheed Martin and the Department of Defense arrived at was stealth. Reduce the aircraft's radar cross-section to the point where conventional air defense systems cannot generate a reliable track, cannot lock on with sufficient confidence to engage, and cannot coordinate an effective response before the aircraft has completed its mission and departed the threat environment. On paper and in the test environments where the F-35's capabilities were evaluated and marketed to Congress, to allied governments, and to the American public, the aircraft performed impressively against conventional radar-based air defense systems. The radar cross-section was reduced to a level comparable to a large bird. The internal weapons carriage eliminated the radar return that external pylons would generate. The radar-absorbing surface coatings degraded the quality of return signals to the point where many legacy air defense systems could not achieve reliable track. The program cost over $400 billion to develop. It took decades. It involved the combined engineering resources of the United States and multiple allied nations, and it produced an aircraft that its advocates described as the most survivable combat jet in human history. But there is a principle that every officer who has commanded forces in the field understands at a level that goes beyond doctrine. Capabilities that are evaluated in controlled environments are not the same as capabilities that are proven in combat, and the assumptions that underpin a weapon system's design are only as valid as the threat environment remains consistent with those assumptions. The F-35 was designed to defeat radar, and it does that effectively. What it was not designed to defeat, what its architects acknowledged as a limitation, and what the program's advocates consistently downplayed in public forums, is the full spectrum of detection technologies that a sophisticated, adaptive adversary can bring to bear. Radar is one tool. It is not the only tool. And Iran, with significant assistance from Russia and China, has spent years developing and deploying detection systems that do not rely on radar as their primary sensor. That is the core of what happened here, and understanding it requires us to go deeper into the physics of stealth and the evolution of modern air defense than most public commentary has been willing to go. Stealth, properly understood, is not invisibility, it is signature management. An F-35 in flight is not invisible to every sensor in the electromagnetic and physical spectrum. It is specifically designed to minimize its return on radar frequencies that conventional air defense systems use for target acquisition and fire control. But an aircraft in flight generates multiple signatures simultaneously. It generates a radar return, which the F-35 manages effectively. It generates an acoustic signature, which is less tactically significant at the altitudes and speeds at which the aircraft operates, but is not zero. It generates an electronic emission signature from the complex array of sensors, communication systems, electronic warfare equipment, and software systems that make the F-35 the flying computer it is designed to be. And it generates a thermal signature, heat, the product of a jet engine producing the thrust necessary to move a 35,000-pound aircraft through the atmosphere at speeds exceeding Mach 1.6. That heat does not disappear because the aircraft has been coated in radar-absorbing material. It trails behind the aircraft as a persistent, detectable, trackable infrared signature, and that signature is the vulnerability that Iran exploited. The specific detection technology involved is what defense analysts refer to as infrared search and track, or IRST. These are passive sensor systems, meaning they do not emit any signal that the targeted aircraft's electronic warfare suite can detect. They simply listen. They search the infrared spectrum for the thermal emissions that jet propulsion systems inevitably produce, and they build a track based on the heat signature rather than a radar return. The F-35's electronic warfare systems are sophisticated. They are designed to detect, characterize, and respond to radar emissions that indicate an enemy air defense system is attempting to track or engage the aircraft. But a passive infrared system emits nothing. There is nothing for the electronic warfare suite to detect. The pilot receives no warning. The threat display shows nothing. And all the while, the IRST system is building an increasingly precise track of the aircraft's position, altitude, speed, and projected flight path. This is not a theoretical vulnerability that exists only in laboratory simulations. Defense researchers and independent analysts have been documenting and publishing concerns about exactly this detection method for years. The technical reports are in the open literature. The retired officers who raised these concerns in official forums did so repeatedly and on the record. The response from the program's institutional advocates was consistent. The F-35's operational concepts and mission planning procedures would mitigate the risk. That response, as this incident demonstrates, was insufficient. Iran did not develop its IRST capability in isolation. The technology transfer that enabled Tehran to field a meaningful infrared detection network is itself a significant intelligence and policy failure that deserves direct examination. Russia has operated advanced IRST systems on its own fighter aircraft for decades. The Su-35, which Russia has exported to multiple nations and which has been operated in environments adjacent to this conflict zone, carries an IRST system that is among the most capable in the world. China has invested heavily in IRST technology as a specific counter to American stealth aircraft, recognizing that defeating radar-based detection is the cornerstone of fifth-generation air power, and that the most effective way to negate that advantage is to shift the detection paradigm entirely. The intelligence-sharing relationship between Russia, China, and Iran is not a secret. It has been documented in open-source reporting and in congressional testimony. What has not been adequately communicated to the American public is the degree to which that intelligence sharing has specifically focused on American weapon systems and their exploitable weaknesses. The vulnerability Iran used to engage this aircraft was not discovered independently. It was transferred, and the fact that it has now been demonstrated in a real combat engagement means it is no longer theoretical for any adversary watching. Stay with me, because what I am about to explain about the tactical execution of this engagement reveals a level of operational sophistication from Iran that the American national security establishment has consistently underestimated, and understanding it is essential to grasping the full strategic weight of what occurred. Iran's air defense network is not a simple system. It is a layered architecture that has been built, adapted, and refined over years of operating under sanctions that prevented Tehran from purchasing the most advanced systems available on the international market. That constraint, paradoxically, accelerated Iran's domestic weapons development in ways that produced capabilities that are in some respects more operationally relevant than imported systems would have been, because they were designed specifically around the threat environment Iran anticipated facing. The engagement of this F-35 almost certainly did not involve a single system acting in isolation. What the available evidence suggests is a coordinated network detection operation in which multiple passive sensors positioned across a wide geographic area fed data to a central processing architecture that fused those inputs into a composite track of sufficient quality to support a fire control solution. The critical operational detail is the word passive. Every sensor in this network was listening, not transmitting. The F-35's electronic warfare suite, which is designed to detect and respond to active radar emissions, had nothing to work with. The pilot was operating in an environment that his systems told him was clear of active threats, while a passive network was building a precise picture of his aircraft's position with every second that passed. Once that composite track reached the confidence threshold necessary to support an engagement, a surface-to-air missile was launched. And here the sophistication of the engagement becomes even more significant. The missile was not guided to the target by a radar beam that the F-35 systems could have detected and responded to with electronic countermeasures or evasive maneuvering. It was guided by a projected flight path calculation derived from the passive track, with a terminal infrared seeker to close the final distance to the target. The F-35's radar warning receiver, which monitors for the specific emissions associated with radar-guided missile engagements, would have shown nothing until the missile's own seeker activated in the terminal phase of the engagement. At that point, the geometry of the situation, the closing speed of the missile, and the distance remaining may have left the pilot with seconds to respond. Based on what the reporting indicates about the outcome, those seconds were not enough. The loss of this aircraft is not simply a military event. It is a political, strategic, and institutional earthquake whose aftershocks will be felt across the entire architecture of American and Allied defense planning. And if you think what I have described so far represents the full scope of this crisis, I need you to understand that we have not yet addressed the most consequential dimension of what this incident means. The geopolitical implications, the intelligence catastrophe represented by the wreckage of this aircraft, the questions about institutional honesty within the F-35 program, and the direct implications for a potential conflict over Taiwan are all still ahead. Stay with me, because the strategic picture that emerges from those dimensions is more serious than anything I've described so far. Let me address directly what the loss of this aircraft means from an intelligence standpoint, because this dimension of the incident has received far less attention than it deserves, and it is in many respects the most immediately consequential aspect of what occurred. When a stealth aircraft goes down in hostile territory, the wreckage does not simply represent the loss of a weapons platform. It represents the potential compromise of some of the most closely guarded technological secrets in the American defense arsenal. The F-35's stealth coatings, the specific composition and application methods of its radar-absorbing materials, are classified at the highest levels. The aircraft's avionics architecture, its sensor fusion systems, its electronic warfare suite, and the software that integrates all of those components into a coherent operational capability represent decades of investment and innovation that adversaries have been attempting to replicate and counter for years. If Iran has recovered meaningful portions of this aircraft's wreckage, and the reporting suggests that is precisely what has occurred, then the clock has already started on a reverse engineering effort that will involve not just Iranian technicians, but the full technical resources of Russia and China. The intelligence sharing agreements between those three nations with respect to captured American military technology are well documented. What Iran recovers, Russia and China will have access to within weeks. That is not speculation. That is the established pattern of how this relationship has functioned in previous incidents involving captured American equipment. The specific concern that defense and intelligence officials will be focused on in the immediate term is the stealth materials. Understanding the precise composition of the F-35's radar-absorbing coatings, the thickness and layering of those materials, and the specific frequencies they are designed to attenuate would allow Chinese engineers to design radar systems that are specifically optimized to defeat those coatings. China has been working on this problem for years using publicly available information, theoretical analysis, and whatever intelligence it has been able to collect through other means. Access to physical samples of the actual materials from an actual aircraft would accelerate that work in ways that are difficult to overstate. The timeline for China fielding radar systems specifically optimized to counter F-35 stealth could be compressed by years. And every year that timeline compresses is a year less of operational advantage for the United States and its allies in the Pacific theater, where the F-35 is the cornerstone of the air power strategy for a potential conflict over Taiwan or in the South China Sea. Beyond the materials, the avionics and software systems recovered from the wreckage represent a counterintelligence challenge of the first order. The F-35's mission computer, if recovered in a condition that allows meaningful analysis, could provide adversaries with detailed insight into the aircraft's sensor architecture, its electronic warfare protocols, and potentially elements of its communications and data link systems. American and allied intelligence agencies will be working urgently to assess exactly what was recovered, what condition it is in, and what level of exploitation is technically feasible. That assessment will drive decisions about whether specific software systems need to be updated, whether communications protocols need to be changed, and whether any of the classified operational procedures associated with F-35 missions need to be revised to account for the possibility that adversaries now have greater insight into how the aircraft operates than they did before this incident occurred. This is an enormous amount of consequential work that needs to happen quickly, and it is happening against the backdrop of a public and political environment that is demanding answers about how this was allowed to occur in the first place. The political dimensions of this incident are significant, and they will play out over months and years, not days and weeks. Congress will demand classified briefings. The questions that members of the Armed Services Committees and the Intelligence Committees will be asking are not comfortable ones for either the Department of Defense or for Lockheed Martin. The central question, and it is a question that goes to the heart of the institutional integrity of the American defense acquisition process, is what did program officials know about the F-35's vulnerability to infrared detection systems? When did they know it? And what did they tell Congress and allied governments about that vulnerability during the procurement process? The reporting that has emerged suggests that internal assessments of the aircraft's infrared vulnerability were available to program officials, and that those assessments were not communicated with the degree of transparency that the procurement process demands. If that is substantiated through congressional investigation, we are not simply looking at a military failure. We are looking at a failure of institutional honesty that has direct implications for the credibility of American defense procurement across every major program. The men and women who fly these aircraft made their peace with the risks of combat aviation. What they are entitled to is an honest accounting of what those risks actually are. If they were sent into contested airspace with an incomplete picture of their aircraft's vulnerabilities because program officials were protecting a budget line, that is a moral failure as much as it is an institutional one, and it demands accountability at every level where that decision was made. The allied nations that have purchased the F-35 based on American assurances about its capabilities are now in a position of having to reassess the foundational assumptions of their air defense strategies. Israel has integrated the F-35, which it designates the Adir, into its operational concept for conducting strikes in heavily defended airspace, including potential operations against Iranian nuclear facilities. Japan has structured its air defense response to the Chinese threat around the F-35's stealth capabilities. The Netherlands, Norway, Australia, the United Kingdom, and other NATO partners have made procurement decisions and force structure decisions based on the aircraft's promised survivability. Every one of those nations is now engaged in urgent consultations with their own defense establishments and with their American counterparts about what this incident means for the operational assumptions that underpin their security planning. Those conversations are happening right now in classified settings with a degree of urgency that reflects the seriousness of what has occurred. And the answers that American officials are able to provide will have lasting consequences for the credibility of American defense guarantees across the alliance structure. And if you think the Allied reassessment is the most serious geopolitical consequence of this incident, I need you to understand that the deterrence implications extend considerably further and are in some respects more immediately dangerous. The foundation of American conventional deterrence in the post-Cold War era has rested on a specific proposition that the technological superiority of American military systems is so pronounced, so comprehensive, and so reliably demonstrated that potential adversaries will calculate that the costs of directly confronting American forces exceed any conceivable benefit. That proposition has never been absolute. No serious defense analyst has ever argued that American military technology is invulnerable. But the perception of overwhelming technological advantage has a deterrent effect that is distinct from the reality of that advantage, and it has been a significant factor in the decision-making calculus of potential adversaries across multiple theaters. When the most visible symbol of American air power superiority is publicly demonstrated to be defeatable by a second-tier military power using technology that was transferred from Russia and China, that perception changes, not completely, not overnight, but in the specific, targeted, calculated way that adversaries are always looking for when they assess where the boundaries of American deterrence actually lie. North Korea's leadership is drawing conclusions from this incident. Iranian-aligned proxy forces across the Middle East are drawing conclusions. Venezuelan military planners are drawing conclusions. And most significantly, Chinese military strategists who have been working for years on the specific problem of defeating American stealth aircraft in a Taiwan contingency are drawing conclusions. China's investment in passive detection technology, in IRST systems, in low-frequency radar that trades resolution for the ability to detect stealth aircraft at operationally relevant ranges, has been driven by exactly the analytical framework that this incident validates. Chinese air defense planners have long argued internally that fifth-generation stealth is a manageable challenge rather than an insurmountable one, that the solution is a layered, multi-spectral detection architecture rather than a single-mode radar system, and that a networked passive detection capability combined with long-range surface-to-air missiles represents a credible counter to American stealth aircraft. This incident does not give China capabilities it did not previously have. What it does is validate the strategic investment China has made in those capabilities and accelerate the confidence with which Chinese planners will incorporate anti-stealth assumptions into their operational planning for a potential Taiwan contingency.